Welcome back, data detectives. Are you ready to take your EDA skills to next level? Today, we'll deep dive into the crucial task of ensuring data integrity. It's like giving your data a thorough health checkup before making any big decisions based on it. We have to make sure a concept that is data integrity. So data integrity means your data is accurate, consistent, and reliable. It is the foundation for trustworthy analysis. So here are some common data integrity issues, right? So starting with the first thing that can be missing values. Your data may contain many missing values that will cause harm to your data integrity, right? Missing values are the data points that are absent or incomplete in a dataset. They can occur for various reasons. They may be due to like data collection errors. They may be due to like technical glitches. They may be due to some privacy concerns, right? Like sensitive information that are withheld with the company. Or one reason more, there could be like data entry mistake. So these could be the potential causes for your missing values, right? Show you a bar chart with gaps will effectively illustrates missing values, right? Each bar represents a variable and the gaps within the bar showcase the missing data points, right? So your missing values may impact your data, right? What could be the impacts of your missing values to your data, right? Potential impacts. You could see statistical powers, reduced statistical powers, right? They can weaken the ability to statistically test to detect significant patterns, right? And you will have a compromised machine learning model that may not have pretty much good accuracy or accuracy as we want. Compromised machine learning models, right? So these could be some impact that missing values could have. So given a data set, how will you check for missing values present inside that given data set? For example, here I'm given with a data set that is Titanic data set. This is the data set. So guys, suppose this is the data set and I want to figure out how many missing values are present inside this data set. Like there are multiple variables like passenger ID, survived, P-class, name, sex, age, sibling, parts, tech ticket, fare, cabin, and there are multiple column, right? So suppose I want to find this is a missing value, right? This is empty. So I want to find how many missing values are present there and which column contains how many number of missing values, right? And if possible, we will try to plot a bar graph out of it, okay? So let's import this data to our collab file. So by clicking here on this button, you can upload your dataset, right? So I have already imported my dataset that is tested.csv. Now I will import the necessary libraries, right? So first of all, let's import pandas as PD, right? PD is an alias that will help us to use pandas whenever we require. We'll just type PD instead of writing again and again pandas. It will save our time, okay? And I'm importing matplotlib that will help us to plot graphs and that by and importing it, giving it alias plt. Now we are loading our data set and giving it this name data, okay? So data is equals to pd.read_csv, and inside this we are giving a path of our file. That is, we'll copy the path and give it inside here. We'll give it double quotes and paste the path of the file. And if I see it, data.head, I should be given with that particular data, right? You can see it here. Now let's create a bar chart, okay, showing some missing values, right? So how could we do that? Let me just type the code here, okay? So first of all, what we'll do, we will use a figure class inside PLT, figure method inside PLT. We'll use it by plt.figure. Inside this, we will pass a parameter that is figure is equals to, that inside that we have to pass 10 comma, we can say 10 comma 6. These are the parameters that we can change according to our requirement, okay? So now if we will see data.null is null. This is a data frame function, is null is a data frame function that will show us for the missing values, right? And then we are summing it up and creating a plot by passing a parameter that is kind is equals to bar. That should be inside your quotes, right? Now what we will be doing is we will be giving it a title. So by using plt.title, we can give it a title. So suppose say we can give it title and we can give it missing value per variable, right? So for every variable, we'll try to figure out how many missing values are there in that particular feature. Now we will see print the x label and give it a name that is variable, right? For that on y-axis we want to display suppose say x label. Inside that we will say number of missing values, right? I did a mistake here, so I'm going to erase it. Okay, so now after completing this, our plot is already finished. Now what we will do is we will run plt.show. What this plt.show will does is it will display us the chart. So now it should give me a graph that is here. So you will see that there are no null values or missing values inside passenger ID, survived, places, name. We got two variables in which we have missing values. In age, we have something around like 80, and in cabin we have like 300, right? So might be the cabin empty. Yep, we see this cabin is completely empty now, or very less values are filled there. So by this drawing this plot, we can see that. Now we will see some numerical summary of missingness, right? So if you want to see numbers, you just want to see numerically what is the number of missing values. You will say is null dot sum as we used earlier on the while plotting the graph. You will find that you have got the numbers like age is 86, cabin is 327. And after that, if you want to find the mean of it, like you can say is null, like it will give you a arithmetic mean of it. Is null dot mean. You can use multiple methods inside here. Like you have mean, and it will give you the mean. Like 20% of the data is empty. Like 78% of the data from cabin is empty. Suppose you want to check for missing values in specific columns, right? So how you will do that is by data, you will pass here the column name. Like suppose I want to check for age. For age, I want to see how many null values are there. I will say is null dot sum and I will return. It will give me the missing values for it here, right? Now we can identify missing value types, right? So if I print data dot is NA, is NA, and then I print, so it will give a true or false. Missing values it will say true, and for non-missing values it will say false, right? Now you can see here what numbers we have put here. Okay. So we have discussed about our common data integrity issue, that is missing values. So there is another data integrity issue, that is outliers. So outliers are basically the data points that significantly deviate from the typical pattern or distribution of rest of the data. They can arise due to like measurement issue, or they may arise due to rare events, or like data entry mistakes, or there may be a natural cause, right? Like natural variability. So this may cause potential impact to our data, right? Having outliers on our data is not a good thing, because it may basically distort of the statistical measures, lead to distortion of statistical measures. Outliers can significantly impact averages, right? Standard deviations and correlations, leading to misleading interpretations. That is harmful for our analysis. Another thing is masking of true patterns. It basically don't show you the actual pattern or actual information that our data want to convey to us. They can hide genuine patterns and relationship within the data, right? Another impact that our outlier could have on our data is misinterpretation of results. Right? Outliers can lead to incorrect conclusion and misguided decisions, right? So now let's look at some coding behind it. How do we figure out and see statistical method for outlier detections, right? So now let's talk about some coding part behind the outliers, right? So basically visualizing outliers with a scatter plot is hopefully done on the previous module. So we will start with some statistical method for outlier detection, right? Like z-score. If you have heard about it or read about it in your mathematical class, we have a concept of z-score and interquartile ranges that we can perform using Python. So let me write a code. It will take a bit and hope you understand. If you have gone through the high school math, data inside this, we have a variable, we may pass age, subtract it with the data variable, and that is age. And if we get the mean and divide it with data age and standard deviation, STD. There is a pre-built method in the data frame that will help us to find the standard deviation. After that, we will see absolute. So we can see statistical method for outliers detection using Python pandas functions. Okay, so it's a pretty much big code that I have already pasted here so that it may save our time. So basically what it does is it will find the quartile 1 and it will find quartile 3 and it will find the interquartile range, that is Q3 minus Q1, and it will find lower bound, upper bound, and it will find the potential errors. Okay, so what are the outliers? Basically outliers, any value that will lie above quartile 3 and below quartile 1, right? And so here's the formula for that. So we are applying that, and if I run this, it get loaded, and when I run it potential outliers, it should show me the rows with that contains age as outliers. So let's see some output, right? So it has given us two values. That is, in this you may see that age is 67 and 76. This might be the outlier, right? Because this is pretty big age. For it is not like a normal, like most of the people would lie between 20 or to 50, suppose, for example, right? And only these two lie above 50 or 60. And what is the particular value for the IQR data or for lower bound and upper bound, right? If you will plot some box plot for visualization, distribution, and outliers, you will see you can do that with this data dot box plot, and simply you will pass here the age, and you can see any value that will lie above this 40 and below this 20 will be an outlier. So the data point here is 67 and 76 that will particularly lie between here and here, this and this. So these are outliers, right? They may fit for the definition to be called as outliers. A scatter plot is an excellent tool to visualize outliers, and isolated outliers point far away from the main cluster of the data points visually suggests an outliers. So here you may see that these points, these and these are separated with the main cluster. So these may be potentially the outliers, and they may hamper our data accuracy. Like if you draw a simple linear regression line, it might fit like that. But if you have some outliers, or if the data set contains some more outliers, so it will basically make our data inaccurate, because these are basically the outliers, but it is affecting our model, right? So this may eventually impact our accuracy of our machine learning model or deep learning model or anything that we are want to try to analyze or predict with that particular data set, right? Reason for data integrity maybe is data type inconsistency. So the data type inconsistency occurs when variables in a data set are assigned incorrect or mismatched data types. This can happen due to the reason for it is data collection and entry errors, similar to those we talked earlier. Okay, so no point of writing it again and again. So the point are similar data collection and entry errors, mixing data from different sources, inconsistent formatting, software glitches, right? And some impact of data inconsistency may be calculation errors. Incorrect data types can lead to error in mathematical operations and statistical analysis, right? So this is worth writing. Calculation errors. And other is analysis disruption. Analysis disruption means they can prevent certain types of analysis or that will cause unexpected results, right? And it may also cause visual distortion, right? Inconsistent types can produce misleading or incorrect visualization, right? So here are some code in Python that will help us to understand data type inconsistencies, right? So here is some code that will help. Here is some Python code that will help to understand data inconsistency, right? So first of all, we will check for the overall data type. So right, to check overall data type, we can use data.dtypes. This will show us all the data type of every feature or every column that we have inside our data set, right? In passenger, you can see it is integer, 64 survived is integer, p class is integer, name is an object, right? And similarly, you can see for further columns we have given a data type, right? Suppose say if you want to check data type for specific column, that you can do like by data, and inside brackets you can pass column name, suppose say age, and you will say dot d types. It will give you the d type of the particular column and that specific column, right? Now you can visualize the data types in a table, right? You can create a table with each column's name, data type, and sample value for visual inspection, right? Suppose say if you want that, you can do with data.head function that I also showed you earlier, but it has some feature or some parameters that will help you to get about your data no more. Suppose say if you want to set it into, align it to it in between the centers, right? You have set underscore properties, and in that you have to pass like text align. Suppose say we want to make it center, right? When I run this, center align the data, the text is aligned into the center. Okay. So similarly, you can play around with it by seeing the documentation of pandas and data frame, right? And now we have left two other data integrity issues, right? First one is duplicate entries, and the other is incorrect formatting. Okay. So duplicate entries are basically instances where the same data points appears multiple times in a dataset, creating redundancy and potential bias. They often may arise due to accidental data entry errors, merging multiple dataset, and technical glitches, right? So let us write some code on Python to see how to figure out duplicate entries. So how you can flag out for duplicate rows if present on your dataset. I think for this dataset we don't have any duplicate entries, but we may check it. We can say duplicate underscore rows, and inside pandas data frame we have data dot duplicated, and it should show us all the duplicated row, right? So see, if I print duplicate row, so it should print us if any duplicate errors are there. So I'm doing something wrong, duplicate. So if I run this, I should get some duplicate row if there would be any. So you may see we got an empty dataset, means there are no duplicate rows. Okay. So if you want to say, suppose count duplicates, you also have another function that is not another function, but you can simply do like data dot duplicated dot sum. It will print to the total number of duplicate entries that are present inside your data set, right? If I print num underscore dp, it should show me the number of duplicate entries, right? Because there are no, so we would get 0, right? So this was it, okay, for duplicate entries. And now we can do some handling duplicate values, right? For handling duplicate values, we have some multiple ways. Like we can remove duplicates, or keep only the first occurrence of each duplicate, or keep only the last occurrence of each duplicate. Okay, so starting with the removing duplicate, we can remove duplicate by doing drop duplicates. We have data is equals to unique. It will create another data frame, and that will be and for that we will be using a function present inside pandas class, that is drop underscore duplicates, right? And it will drop the duplicates if the duplicates would be present there. And suppose say if you want to keep the first duplicate value, this might be your assignment or your practice work, or your way to get your hands dirty with coding, is you may try this code out with another data set that might contain some duplicate values. So it will give you a pretty basic idea of how duplicate entries are removed, right? So you may try it on your own. We have duplicate.drop underscore, we have duplicates of duplicates, and we can say keep first, right? If you run this, we'll get a new data set that will be a data frame that is data underscore unique, and it will remove all the duplicate values except first one, right? Similarly for the last, we have to change it to last, right?